All right, hello. We're going to do another lesson here. We're going to do probability and data management. This is Unit 16. We're going to do our third lesson in this unit, which is 8-18, Theoretical Probability Review. And this is a fun one because it ties in with game theory. So if you like games of chance, if you like board games, this is probably right up your alley here. So we're going to get started. This is on page 197 of your Jump Math workbook. So let's take a look at this first gray box here. This spinner has 4 regions, so there are 4 outcomes. So an outcome is simply a possible chance. Okay? The spinner will land in either B, R, B, or B. There's 4 different outcomes, and all 4 outcomes are equally likely to happen. And they are equally likely to happen because, ding, 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 you guessed it, they're all the same size. The angle for each arc is the exact same. Now, this spinner has 2 regions. They've got a big B region and a small R region. So there are 2 possible outcomes. You could get B or you could get R. That's the only possible outcomes, but they are not equally likely to happen. The reason why is because B is 3 times larger than R. So you're much more likely to land in the big B zone than in the smaller R zone. So this is theoretical probability. This is outcomes and whether they are equally likely or not equally likely. Let's take a look at question 1. How many different outcomes are there when you roll a die? So they're talking about a die that you would have in a board game. Die is singular, dice is plural. So on a single die, do I have one in my desk here? Oh, great. The only one I have is this one. This is not a typical die. This is actually a 12-sided die. In a typical die, there is only 6 sides. So how many different outcomes when you roll a die? There are 6 outcomes. How about when you flip a coin? I've got some pennies in my desk here. If I flip a coin, where's my camera? I've got 2 outcomes. I could get tails or I could get heads. Heads or tails. 2 outcomes. Play hockey. Ooh, this one's tougher. I could win. I could lose. Is there a tie in hockey? I don't think there is. Isn't there overtime? I think it's only win or lose. I'm pretty sure, at least in the NHL, it's just overtime. 3 outcomes if there's a tie. Number 2, what are the possible outcomes for the spinner? Well, it could land in region 1, in region 2, region 3, or region 4. There are a total of 4 outcomes. What about in the second one? How many outcomes are there? Let's check that one out. It looks like there are 3 different regions. Okay, so I'd like you to list the regions and number the outcomes. Number 3, you draw a colored marble from the box. How many different outcomes are there? Are the outcomes equally likely to happen? So I've got a red, a blue, and a green marble in a box. Okay, there's a total of 3 outcomes. I could pick the red, I could pick the blue, or the green. Are they equally likely? Yes, because there's 1 of each. Now in this one, there are 4 outcomes because there's 4 marbles. Are they equally likely? There's a yellow, green, blue, and red. There's 1 of each, so yes, they are equally likely. Let's check out number 4. Again, I really like games, so you could probably tell I'm excited here. You spin the spinner. How many different outcomes are there? Are the outcomes equally likely to happen? In this one here, there's 5 different zones, so there's 5 possible outcomes. Are they equally likely? Yes. Yes, they are equally likely. I noticed that 2 are labeled A, 2 are labeled B, and C. is just 1. So you're more likely to get an A, but you have an equal chance of getting in each zone. Okay? Maybe that's what is that what they mean? I'm going to change my answer there. No. You are more likely to get an A or a B than a C, because C is a smaller zone. It's only got 1 zone. The other ones have 2. In this one here, there are 1, 2, 3, 4, 5 possible outcomes. Are they equally likely? Yes, they are equally likely, because there's 2 zones for A, 2 zones for B, but if you put A and B together, or the A's and the B's together, they would be the same size as C, so they're equally likely. There's a total of 6 outcomes here, because there's 6 different spots. Equally likely, there's 2 A's, there's 2 B's, 1 C and 1 D. Not equally likely. And finally, the bonus. Let's check that one out. I got to move this up because my camera's in the way. Whoops. Need my pointer here. Maybe we can move the camera down. Look at that, looks better. Okay, bonus. How many outcomes? A, B, C, D, E, F. There's 6 different zones there. Are they equally likely? Ooh, what do you think? Are all of the angles, the inside angles in the circle here, the same? Doesn't it look like B is smaller than F? I'm pretty sure it is. I'm going to say not equally likely, because I don't think the size of the zones is the same. Okay, let's move down here to the next page. There are 4 equal regions in the spinner, so there are 4 equally likely outcomes. You can spin red in 3 different ways. So in this one here, we've got 4 outcomes. They're all equal size. So my probability of spinning red is 3 out of 4. So 3 out of 4 is number of ways of spinning red is my 3. Number of spinning any color is 4, because there's 4 outcomes. And if I want red, it's 3 out of 4 or 3 to 4. 3 out of 4 would be equal to, of course, 0.75. When the outcomes are equally likely, the probability of an event is the number of outcomes that suit the event divided by the total number of all outcomes. That's the formula. So when you want the probability of something happening, you're like, well, how many outcomes match the criteria, and how many possible outcomes are there? So let's take a look at a practical application of this here. Number 5, how many ways are there to draw a green marble? Well, there's only one way, isn't there? Because there's only one green marble, right? How many different ways are there to draw a marble of any color? Well, there's a total of 3 marbles there. Okay. What about this one here? To spin green. How many different ways can you spin green? Well, there's 1, 2, 3. 3. Yeah. Spin any color. Well, there's a total of 8 zones. Okay, good. Now we're going to look at the probability of each one of these happening here. So if I look at probability of spinning red, for example, these are all 5 equal zones there. There are 2 chances to spin red. There's 2 zones that are red, and there's a total of 5 different outcomes. So the probability of spinning red is 2/5, which is equal to 0.40 or 40%. I would have a 40% chance of spinning red. What about this one? Green and red. Well, there's 1 red zone and there's 2 possible outcomes. So my probability is 1/2, which is 0.5 or 50%. And you can see that you've got a 50% chance of spinning red there. What about the probability of red there? There's 2 possible red zones, 4 possible outcomes. So I've got 2/4, which is equal to 0.5 or 50%. What about here? I've got 2 possible reds out of 3 zones. So 2 divided by 3 is 0.6 repeating, which is about 67%. It's 66.6 repeating. So that's the way we calculate probability, is simply to look at the total or the chances of that outcome by saying, well, how many options do I have to get that event, and what are the total number of possible outcomes? Let's take a look at number 7. If a dart always lands on the board with each region equally likely, what's the probability of hitting blue? Reduce your answers if possible. So in this one here, there's 2 zones that are marked blue, there and there. So the probability of blue is 2 out of 4 zones. And they say reduce, so that would be 1/2, which you already know from the previous question is 50%. What about this one here? There's 3 zones, and one of them is blue, so it's 1 out of 3. Well, we can't reduce that one, but we would know that that one is roughly 33%. I'll let you do C and D on your own. Calculate the number of zones that are blue divided by the total number of zones. Number 8, add lines to divide the spinner to make all the outcomes equally likely. Find the probability. So we're going to have to divide this one in 2 to make that equally likely. There we go. Now I've got 6 zones. The probability of getting blue is 1, 2, 3, 4 zones out of 6, which is equal to 2 out of 3 when I reduce. If I divide this W, white zone, in 2, then my probability of getting red is 1 out of 4 zones, which is about 25%. Go ahead and do C and D on your own. Divide them up so that they're equal zones there, or equal outcomes, and then figure out the probability of getting a yellow on C or a green on D. Let's move on. Okay, write a fraction that gives the probability of spinning. Oh, here we've got a little spinner right there. This is totally the type of games that my son plays with me. He's got this barnyard bingo game, and it's got a spinner, and you have to spin the different animals. You just flick it and that sort of stuff, and it lands on like the purple pig or the blue goose or the green horse. So this is totally, I should teach him this lesson, but he is only 3, so that would not be great. Number 9, write a fraction that gives the probability of spinning the number 1. Well, the number 1 is one of the outcomes. There's a total of 8 outcomes because there's 8 different zones. So the probability of spinning a 1 is 1 out of 8. What's the probability of spinning a number 3? Well, the 3, there's only one 3, so there's 1 out of 8 for 3s. An even number. Well, 8 is even and 12 is even. Those are the only 2 even numbers. So there's 2 out of 8, which is equal to 1/4. An odd number. All of the other ones are odd, so that's 6 out of 8, which is 3 out of 4. That's 75% chance of getting an odd number. I'll let you do E and F on your own. Write a fraction that gives the probability of spinning one of those numbers. Okay, so let's move on to the next one. Remember, a regular die is a cube with the numbers 1 to 6 on its faces. Dice can also come in different shapes and have different numbers on their faces. And an example of that is this one here. Okay, so this has got 12 faces. There was a really cool game called Globetrotters that had a 12-sided die. List the numbers on a regular die. Well, let's do that then. 1, 2, 3, 4, 5. What's the last one? Yeah, 6. How many outcomes are there when you roll a regular die? There's 6 different outcomes, 6 different faces on that cube. List the numbers on a regular die that are even. 2, 4, 6. How many ways can you roll an even number? Well, 3 different ways. What's the probability of rolling an even number? 3 out of 6, or 1/2. Your probability of rolling an even number on a dice is 1/2. Go ahead and do question 12 on your own. It's just looking at probability of rolling a number greater than 4. Let's take a look at 13. Match each net for a die to the correct statement. Oh, so these are like cubes with different numbers on them. They might have, like this one, for example, 3 of the faces of that die would be 3. That's like a loaded die. Okay, so you match them up. Let's maybe do a couple of those together there. The probability of rolling a 4 is 1 in 6. Well, it's not this one. Can't be A because there's 2 4s. Can't be B because there's 2 4s. Can't be C because there's no 4s. It's D. There's 1 4. So that's got to be D. Okay. The probability of rolling an even number is 1/2. So half the numbers have to be even. Oh, that's A. The probability of, I'll let you do these ones on your own here. 14. Move this up here. Write a fraction that gives the probability of spinning. You can do this one on your own. It's fractions. There's 5 outcomes. Kathy says the probability of rolling 1 on a regular die is 1 in 6. So the probability of rolling a 5 is 5 in 6. Ella says the probability is 1 in 6 for both numbers. Who's right? Explain. Well, Kathy is right when she says the probability of rolling a die, 1 on a regular die is 1 in 6 because there's 1, 1, and there's 6 possible outcomes. Is the probability of rolling a 5 5 out of 6? Well, how many 5s are on a regular die? 1, right? So the odds of rolling a 5 are 1 5 out of 6 possible outcomes. I think Ella is right because the odds of rolling any number on the die is 1 in 6. Okay, and we are going to skip number 16. And that is the lesson of theoretical probability review. And then on the next lesson, we're going to do theoretical probability using that review and applying it. Okay, that's it.